Hi there, welcome to the third question of test 1. Now this question says that you plan to deploy a critical line of business application to Azure. The application will run on an Azure virtual machine. You need to recommend a deployment solution for this application. The solution must provide a guaranteed availability of 99.99%. What is the minimum number of virtual machines you should recommend for the deployment? And the options are 1, 2, 3, and 4. Now this question is all about Azure availability, specifically how we can ensure a certain level of uptime for our application running on an Azure virtual machine. So in this case, we are aiming for 4 nines, 99.99% availability. So what does this have to do with the number of virtual machines? Now the correct answer to this question is 2. We need at least 2 virtual machines for this kind of deployment to have 99.99% availability. So Azure achieves high availability through redundancy and distribution. A single VM, while it can be robust, but it still is a single point of failure. So if something goes wrong with it, your application is down, plain and simple. But when you have at least 2 virtual machines, you can place them into 2 availability zones. Now this divides them across different physical infrastructure. So even if one goes down due to maintenance or an unexpected issue, the other one keeps the application up and running, fulfilling that 99.99% availability guarantee. So this is also clearly mentioned in the service level agreement doc for the virtual machines. So let's look at it. So this is the document for SLA for virtual machines, and it has some bullet points. So the first paragraph says that for all virtual machines that have 2 or more instances deployed across 2 or more availability zones in the same Azure region, we guarantee you will have virtual machine connectivity to at least one instance at least 99.99% of the time. So it clearly mentions that if you need to have 99.99% uptime, you must deploy your virtual machines to 2 or more instances across 2 or more availability zones. The rest of the points are for different level of uptime. This is for 99.95%. This is for 99.9%. There are 3 nines. We are looking at 4 nines, and rest of them are 99.5% and 95%. Now let's also look at one more diagram for availability zones and understand why it is important. So here we have some regions: Azure region 1, region 2, region 3, and region 4. A lot of regions support availability zones, but a few regions also do not support availability zones. For example, region 1, region 2 supports availability zones. So there are some availability zones in these regions, while region 3 and region 4 does not have any availability zone as of now. So for example, if we have Azure region 1 and we have 3 different availability zones. So these 3 different availability zones are 3 different physical locations within the same Azure regions. So in order to have a 99.99% uptime for your application, you should have at least 2 virtual machines hosted in 2 different availability zones. So in case of a disaster or an unexpected issue, if a data center in availability zone 2 goes down due to some reasons, your virtual machine in availability zone 1 will still be available and your application will still be up and running. So this is the importance of having your virtual machine spread across 2 different availability zones. That's how you will achieve 99.99% availability. Now going back to the question, the other options are definitely incorrect. The first option 1 is incorrect, as we mentioned that it is simply not enough to guarantee high availability because there is no backup in case of a failure. So it's not the right answer. And as for the options 3 and 4, while they can indeed provide even more redundancy, because there are more number of virtual machines that you can have in different availability zones, but here the question is asking for the minimum number of virtual machines to achieve 99.99% availability. So in this case, the minimum number of virtual machines is 2. Thanks for watching. I'll see you in the next question.